We're given a supply function, this square root function right here, and what we want to do is find the producer surplus if the equilibrium point, xp, is this ordered pair right here, 35, 7.07. Let's be sure we understand what everything means up here. What does this mean here, and what does this mean here? Let's talk about this one right here. What is S of x? Well, S of x, this represents the price, all right? So it's a price. It's a dollar amount. Represents the price per unit of some product at which producers are willing to produce and supply X units of some product. So that's what X is right here. X is the number of units that a supplier is willing to produce and supply to the market at that price. And that price right there is really going to be related to this. So what we've got here is this, is that if the price per unit is $7.07, this producer is willing to produce and supply 35 units of some product. Now, our supply function is this square root function right here. Now I'm going to draw that square root function over here. Square root function is this will be x, this will be s. Now x is the number of units a supplier, a manufacturer, is willing to produce and put on the market at this price. Now remember, s is the price. And the square root function looks like this. Just a general square root function. And what we're saying here is this, is that if the price is this much right here, say, then follow it over and down, at that price, this manufacturer or supplier is willing to produce and put on the market this many units of some product. I'll draw that in here. So if the price is this much right here, follow it over and down, the producer is willing to put on the market this many units of that product. And to get a full picture of what's going on, here is, let's make this a demand curve, right? So this is S, this is D. And then according to our graph here, if at this price, what we have so far, at this price, the supplier is willing to produce and supply this many units. But at this price, kind of a low price maybe, consumers are willing, they would like this many units, right? A lower price, they want more units. So a point at which everyone is happy is this equilibrium point here, right? That's the equilibrium point, and that's that point X sub E, E for equilibrium, and P sub E. So at this price right here, all right, at that price right there, I'll draw it in. So at that price right there, here's the supplier. The supplier is willing to produce and supply this many units of a product. And this price right here is the price that consumers are willing to pay when X units of a product are put on the market. So this point right here, this is a point of satisfaction for both the consumer and the supplier. And that's what we're given right here. So when the price is $7.07, the supplier is willing to supply 35 units of some product. And when there's 35 units of some product put on the market, the consumer is willing to pay $7.07 for each item. Now we are looking for the producer surplus, and the producer surplus is the difference between the total amount consumers actually spend, that's this number right here, and the amount the producers are willing to accept. So that's what this area right in here is, right? That's what we're looking at right here. That is the producer's surplus. So it's an area under a curve. So we're going to take the price. Now see what's happening here. See that? That's the price. That's the equilibrium price right there, minus S. So where are we? We're here minus here. So if we drew in little rectangles, we'd be at what? Price minus S of X. Well, I think hopefully that explains what's going on. Let's actually compute this now. So the producer surplus is going to be the integral from 0 to x sub e, and x sub e for us is 35 of, all right, Now this is going to be P sub e, which is 7.07 minus s of x, which is the square root of x plus 15 dx. This is going to be a little bit of a challenge. Let's break it up into two integrals. 0 to 35 of 7.07 dx minus the integral 0 to 35 of that square root x plus 5 dx. Now I'm going to do it like this. I've got two integrals here. Here's the first one. Here's the second one. So the first one, all right, this integral right here from 0 to 35 of 7.07 dx, that's going to be 7.07. This is just a constant, right? X from 0 to 35. So this is going to be, put in the upper limit, 7.07 times 35 minus 7.07 times 0. And that 7.07 times 35, I got this. So for integral 1, I got 247.45. All right, let me circle that because I'm going to need that later. Now what about for this integral number 2? Here's what we have. We're going to go from 0 to 35 of the square root of x plus 15 dx. Well, the first thing I'm going to do is eliminate that radical. So this is going to be the integral from 0 to 35 of x plus 15 to the 1/2 dx. And now I think we're going to have to use a u substitution for this, right? I've got something to a power, so I'm thinking a u substitution. So what I'm going to try here is to let u equal x plus 15. Now what have I got so far? I've got u to the 1/2. I need the dx, right? I've got u to the 1/2, but I still have to get dx. And if I'm going to do this correctly, that dx should come from here. All right, so u is x plus 15, so what is du dx? That's just 1. And then if you multiply over, du is dx. Now, I'm going to change everything to u's. So that includes the limits of integration. Now I've got u to the 1/2. This turns out to be du. Now what about when x is 0? Now when x equals 0, okay, you know, I should circle that so I can find it. I put 0 back right up in here, and what do I get? When x is 0, u is 0 plus 15, u is 15. Now let's put in the upper limit. When x is equal to 35, u is equal to, or I'll put that 15 back up into x, I'll get 35 plus 15, so u is equal to 50. So our new integral is this one. We're going to integrate between 15 and 50 of u to the 1/2 du. So let's do this. We'll increase the exponent by 1, divide by that new exponent over 3/2 from 15 to 50. Now dividing by 3/2, that's the same as multiplying by 2/3, u to the 3/2 from 15 to 50. Put in our upper limit, we'll get 2/3 times 50 to the 3/2 minus 2/3, put in the lower limit, times 15 to the 3/2. Now I'm going to do that all at once on my calculator, and when I did that, I got 196.97. 196.97. I'll circle that one. Now let's just trace what we were doing here. Come a long way. So what we were trying to do was compute the producer's surplus by this integral here. We broke it into two integrals. The first one went fairly quickly. That was just a linear function. The second one we had to do a little work with because we got u substitution. Right, so we got integral 1 for this one, integral 2 for our u substitution. So if I put it all together, we're right here. We're at integral 1 minus integral 2. So this becomes 247.45 minus that 196.97. And I'm getting 50 point, I'll round it off here, 48. So I'm going to say that the producer's surplus is $50.48.